again, good evening all of you here. Before we start the next session, we have sponsors Petrochem Specialist and Archidis who will be displaying their videos here. May I request Mr. Vasudevan, Petrochem Specialist here. Yeah, specialty. Mr. Vasudevan, sir. It is specialties, right?
And a video film specialties.
Specialties. So, yeah, this is
Good evening, everyone. I'll not take much of your time because we are almost hard pressed for time with a lot of discussions coming on. Just wanted to introduce myself as I'm a channel partner for Petrochem Specialties, and this is a company based out of UP, and it's a ISO 2015 company, and we have products range right from asphalt additive to soil additives, and we strongly believing in academia and industry participation, and that's how we have been working closely with Rasta also, with proper evaluation performance studies, which is still on, and we would like to continue being a partner to the academia at any level with our product range, at our technology presentation. So in fact, Dr. Veeragan also has lent us a lot of ideas how we can be of use to the exchequer and be an active participant in the infrastructure development. Now, there has been a lot of debate on how the challenges have been there in the infrastructure implementation, and we have also come across, as an industry, we have also come across a lot of challenges for that matter. In fact, one of the point Dr. Veeragan had said, even the NRRDA has a system that 15% or 20% to be implemented towards new technology, and we get opportunity in that basis. But again, what happens, a contractor takes maybe, I'm just giving you a small example, if he takes around 10-15 kilometers as a tender, and out of that 20% or 15% goes to new technology, maybe 3-4 kilometers, and he sees the ground performance, but then again that is not getting extrapolated to the balance kilometer actually. So it is getting restricted to the whatever kilometers has been specified for new technology, that is only being done with us. So that awareness has to be percolated down the line. The contractors have to be given the confidence, and how as a industry we continuously participate with the contractors also with the evaluation parameters, and that definitely academia is able to give us, and we have also generated enough reports from the ground, and this is a continual process. And one more thing is, as even as Petrochem, we can also take engineers from Rasta, and in fact one of our engineer is from Rasta currently, and so we are also offering job opportunities not only from Rasta, from other engineering colleges also across the country. So it's a continual process, and we would like to be very actively involved with the academia in any forum, and thanks for the opportunity, and we look forward for more and more interaction and learning as an industry. And we would also like to be open with your comments about the technology, about the value proposition we bring on to the ground. Thank you very much. Yeah, thank you.
Thank you for the support, sir. Now we have a small video from Archidis IBI Group.
आपको जल्दी।
Commissioner, Mr. M.N. Anuchet, and what the department is doing is something extremely interesting. They're using artificial intelligence and the use of drones, especially in choke points in Bengaluru, to identify them and also alleviate the issue. You're also having some interesting data that you're putting together.
Yes.
I'd like to know more from you. Thank you first for joining us here at CNN News 18.
Thank you, Ronnie.
So what is it that you're doing?
So in Bangalore, we are trying to basically do data-driven traffic management. So we have large sources of data in Bangalore. We are collaborating with others as well. We are trying to take this data, analyze it, and have meaningful information, which will then drive our decision. So first of all, we are having data from multiple sources. These sources include our own safety cameras, about 7,500 to 8,000 are there. We have our own 4,000 people on the ground who give us real-time update on the road conditions. It can be a vehicle accident, road block due to waterlogging, vehicle off-road, or a tree fall, which is in real time. We're collecting data from map-based service.
A very good evening to all our distinguished guests, respected dignitaries from government and industry, esteemed academicians, dear students and valued members of infrastructure community. I am Amrita D and it's my privilege to warmly welcome you all to the Professor C.E.G. Justo's 7th Endowment Lecture organized by Rasta in association with ABUHI, Association of Bangalore University Highway Engineering Alumni. We are honored that Rasta has privilege of hosting this program today and we sincerely express our gratitude to our management for the valuable support and cooperation. Rasta is committed to promoting research, innovation and collaboration between academia and the infrastructure industry, particularly in the areas of road technology, transportation engineering and sustainable infrastructure development. Before we further proceed with the session, I would like to invite Mr. Sanjay Justo, son of Professor C.E.G. Justo, on the dais, and I request Professor A. Veeraraghavan sir to present a memento to Sanjay Justo sir on behalf of Rasta. May I now invite Jai Prasad, advisor KRDCL, and he is a close associate with Professor C.J. Justo. And I request Professor A. Veeraraghavan sir to present a memento on behalf of Rasta. May I invite Lokesh from Infra Support and Uday L from Sur Engineers on the dais. And I request Professor A. Veeraraghavan to present a memento as a token of gratitude from Rasta. Thank you, one and all. Thank you, one and all. Further, the session will be continued by Dr. Reshma.
Good evening, everyone. I'm Dr. Reshma, faculty, Rasta, and it is my privilege to warmly welcome you all to the Professor C.E.G. Justo 7th Endowment Lecture, organized by Rasta in association with Abuhay, Association of Bangalore University Highway Engineering Alumni. We are honored that Rasta has the privilege of hosting this program today, and we sincerely express our gratitude to our management for their valuable support and cooperation. Rasta is committed to promoting research, innovation, and collaboration between academia and the infrastructure industry, particularly in the areas of road technology, transportation engineering, and sustainable infrastructure development. To share, the Endowment Lecture Series is conducted in honor of Professor C.E.G. Justo, a legendary figure in the field of highway engineering. Professor Justo made remarkable contributions to pavement engineering, transportation research, and engineering education, inspiring generations of engineers and academicians. To pay tribute and share a few words about his legacy, I invite Professor Justo's most devoted student, who has been very efficiently disseminating his teachings and principles to the younger generations, Professor A. Veeragavan, former professor, IIT Madras, and technical advisor to Rasta, to kindly address the gathering. Sir, may I invite you to share your thoughts with the audience?
Thank you, Reshma. I think I had a very long association with Professor Justo from the year 1980 onwards, when he came as an examiner for my M.Tech thesis. Subsequently, I joined as a scientist at Bangalore University. I did my PhD under the guidance of Professor Justo, and later continued as his colleague in the department till his retirement in 1995. Later, he continued his services as an emeritus professor till 2000. But then, subsequently, we continued our association in Rasta, establishment of Rasta, until the last. I had a very long association from 1980 to 2019. To tell about Professor Justo to the youngsters who may not be knowing of Professor Justo, Professor Chellaya Emmeline Jnana Justo was born to Mr. Nyanaksan Chellaya and Mrs. Lois Chellaya on 11th of March 1935 at Nagarkoil in Tamil Nadu. He had his early school education at Nagarkoil. He graduated with a BSc Engineering degree from the College of Engineering, Trivandrum, Kerala University in the year 1958. He obtained his ME Highways and PhD degree in the field of civil engineering from the University of Roorkee in the years 1960 and 1972 respectively. He was a fellow of the Institution of Engineers, fellow of the Indian Geotechnical Society, member of the Indian Roads Congress, Indian Society for Technical Education. He started his services as a faculty member in the year 1959 at TKM College of Engineering, Kollam, and worked there till 1963. Before moving to Bangalore University, Professor Justo taught at the University of Roorkee, now the IIT Roorkee, for about 10 years from 1963 to 1973, where he guided and trained many postgraduate students. During this period, he also wrote and published textbooks on highway engineering. The book which you are referring today was written by Professor Justo in the year 1971. So the book has not seen any downfall in the purchase or sales or usage by students. There are so many books in highway engineering in the country today, but still highway engineering continues to be the book to be read by all civil engineering students from the last 50 years. So that's a remarkable achievement. Subsequently, he wrote the Highway Materials Testing Book, which was named as Highway Material and Pavement Testing Book. He inducted me as a co-author. The 11th edition of the book of Highway Engineering has now under print, perhaps later this year. You can see the 11th edition of the book with updated IRC codes, guidelines in the next edition. He relinquished services officially in the year 1995 on superannuation from Bangalore University, but he continued to extend the guidance as an emeritus professor till the year 2000. After joining Bangalore University, he took the lead and started the master's degree program in highway engineering at the university and nourished it to be a center of excellence in transport engineering in the country. The Highway Engineering Division of Bangalore University, under his leadership and guidance, has produced hundreds of highly competent highway engineers and scientists who are now occupying key positions in the industry. Some have retired from services, not only in India but abroad as well. Professor Justo strongly believed that what is being taught has to be practiced. This is how he established a strong relationship and bondage with the users of highway department like Karnataka PWD, Traffic Police, Ministry of Road Transport Highways, consultancy companies, construction industry. By his exposure of the students to field problems, he trained them in being practical and effective in the highway engineering field in the country. In addition to academic activities, Professor Justo continued in the administration and policy making at Bangalore University, and the capacities of the head of department, chairman, board of studies, dean of students, principal of University Visvesvaraya College of Engineering, and an interim vice chancellor of Bangalore University. He was also a visiting professor under the Indo-US exchange program at Michigan State University, University of California at Berkeley, and few other institutes in USA during 1989. Apart from teaching and guiding the students and research scholars at the university, Prof. Justo played an effective role in shaping the policies, standards, practices in the field of highway engineering in the country through his participation in various technical research advisory committees as chairman, convener, member, advisor, constituted by the Ministry of Road Transport Highways, Indian Roads Congress, Central Road Research Institute, Karnataka Road Development Corporation, Bangalore Mahanagara Palike, Bangalore Development Authority, Bangalore Metropolitan Corporation, and many more organizations. Prof. Justo was bestowed the Lifetime Achievement Award for his contribution in the field of transportation engineering by the Indian Roads Congress at his 78th annual session in the year 2017. Because of his health, he could not receive the award, but I received the award on his behalf. Later, he was bestowed with the prestigious Justo Award in the year 2019 in the recognition of his dedicated services and contributions to the public through his profession. Prof. Justo left for his heavenly abode on 22nd June 2019. So from then onwards, every year, on the 11th of March on his birthday, we celebrate with an endowment lecture. It's attended by many of his old students here, the friends. I think Mr. Jayaprasad is one of the oldest and close friends of Professor Justo. He attends all the meetings. He took Professor Justo. He took care of his health also till his last. So I welcome Professor Mr. Jayaprasad. I also take the opportunity to welcome Sanjay Justo, Professor Justo's second son. First son is in Dubai. So I welcome Sanjay also to this endowment lecture. I'm sure that this legacy of Professor Justo left, even though he is no more with us, but he is there with us. I think this will continue. This endowment lecture will continue. We'll recall the rich experiences that we gained through his teaching, translating theory to practice. I'm sure this legacy will continue. This 7th endowment lecture is one of the events bestowed in his name and fame. So we look forward to the endowment lecture. We previous years we had with alumni. This year we thought that there is nobody else better than Mr. R.K. Pandey to talk on the topic of current relevance. I think about the issue of sustainability and durability. I think I may now request Mr. R.K. Pandey to deliver the endowment lecture. Thank you very much. He'll introduce.
Thank you, Viragan sir, for those inspiring reflections and for beautifully highlighting the legacy and contributions of Professor Justo. The topic of today's endowment lecture is Decarbonizing Road Construction, Paving the Way to a Sustainable Future. As the infrastructure sector continues to expand rapidly, reducing carbon emissions in road construction has become an important global priority. This topic highlights the need for sustainable materials, innovative technologies, and environmentally responsible practices to build highways that support both development and climate goals. It is now my honor to introduce the speaker for this year's Endowment lecture. Today we are privileged to have Mr. R.K. Pandey, former member technical in NHAI, with us. While many in this distinguished audience already know him very well, for the benefit of our younger students and participants, I would like to briefly share a few highlights of his esteemed career. Mr. Pandey completed his graduation in civil engineering from Government Engineering College, Jabalpur in 1983, and his post-graduation from Maulana Azad College of Technology, Bhopal. He joined the Ministry of Road Transport and Highways as an assistant executive engineer in 1986 and served the ministry in various capacities, rising to the position of additional director general before his superannuation. He also worked at various levels in NHAI and as a member, technical for more than 7 years. He was closely involved in project preparation, project appraisal, contract management, and development and refinement of contract documents, manual standard specifications for national highway projects. Mr. Pandey is an active member of the IRC, a fellow of Institution of Engineers, vice president of IRF, and a member of ING IABAC. He currently serves as an independent director with Vertis. With his vast experience in policy, infrastructure development, and national highway projects, Sir has played a significant role in shaping India's modern highway network. It is indeed my privilege to have him deliver the Professor C.E.G. Justo's 7th Endowment lecture today. On behalf of Rasta, I wholeheartedly welcome you to the session, sir. I now request Dr. Kavita to kindly present a rose as a token of gratitude to Sir. Over to you, sir.
अच्छा ये पकड़ना पड़ेगा सिस्टम ऐसा नहीं है हाँ हाँ आई स्टैंड हियर नो इशू no that's fine I'm perfectly okay but only point is I hope you can hear me good evening everyone friends at the outset I would like to thank Rasta to give me an opportunity to share my views with you. And I begin my presentation with a respectful tribute to Professor Justo. Of course, my association with Professor Justo was very late. I met sometime in 2003 and continue to be in touch with him till he, breath last. For him, describing Professor Justo, a very tough task. Of course, before meeting him, when I was in engineering college, I went to purchase highway engineering book, and the person told me it's a book from father of highway. So since then, I know that Dr. Justo is father of highway. But when I met, really he was a visionary. Visionary. Morning we were discussing about, gap between academia and the profession and this. And I feel that Dr. Justo was a professor who was always at field. He will be only solving problems. So, very difficult to have that kind of people. Only silver lining, his students who are taking forward his legacy. Whatever we like in him, let us try to propagate further and benefit the highway profession. Friends, this particular topic, in this topic I have worked with my colleague Dr. Ambika Bahal. She is scientist in CRRI and I would like to acknowledge her work while presenting this. Whole presentation I have divided into 5 parts. One is the facts. Why we are so much worried about decarbonization in road construction? Where are we today? What is happening internationally? And what we should do now to decarbonize our road sector? Basically, why we are bothered about the decarbonization of road sector. If you see worldwide, the road transport constitute around 20% of the total CO2 emission. And if you see the contribution of road sector in the transportation sector, then we are the major contributor. The CO2 emission on account of road transport in total transportation sector is around 74-75%. Everybody is bothered about, global warming. The target is we should keep the rise in temperature within certain limit before the pre-industrialization session, and that is why the question of decarbonization is important for us. In fact, around the world, people have committed to have net carbon zero. We have also signatory to one of such, and we have committed by 2070, we will be net carbon zero. Of course, when I am talking to you about carbon dioxide, it is not the only gas which is creating all this, There are a number of other gases, but it is the major component. There are other gases who are more potential of warming, but some are short-lived, some are having greater potential, but constitute a very small percentage. So generally, in the common parlance, we only talk about decarbonization. Coming to the Indian condition, whatever I said in the first line, it is the global position. In the Indian condition, the road transport contribution is 90%. Now, question will certainly be in your mind, why 90%, 74%, why it has gone to 90%? The reason is very simple. In India, road transport is the most preferred mode of transport. We have not harnessed our inland waterways. We are not relying much on pipeline. So being the most important mode of transport, it is contributing a lot. Number two, the way our highways are growing up, its contribution is going to be more than that. Now, question comes, what is the role of road improvement? When we are improving a road, there is no doubt in it, we consume a lot of material, we are cutting trees, it is all leading to degradation of environment. But at the same time, when we are improving the road, we are reducing the total fuel consumption on your roads. So this is helping us a lot. In fact, year before last, the CRRI along with number of institutes did a study for Ministry of Environment and Climate Change, and what they summed up with the improvement of road, in fact, it is leading to reduction in fuel consumption, it is leading to net reduction in the carbon dioxide emission. It means by building road, I am not encouraging or not increasing the CO2 emission. The second aspect of it is, even in the morning we have discussed at length, when we talk about road development, of course, CO2 emission is one of the area which we would like to concentrate, but are we considering it as part of our whole process? No, we are not considering. Our whole process is depending on the L1 cost. And when I say L1 cost, of course it is whole life cycle cost, but unfortunately, the sustainability is not included in that. This is the position where we are today. Now again, let us see globally, when we'll have to talk about reduction in carbon emission, what are the sectors which are contributing a lot for carbon emission? One is construction, number 2 industry, agriculture, transport. These are the sectors which are contributing a lot. Of course, we are not bothered about the other sectors. Let us concentrate on the construction. I am not saying road construction, only the construction sector. Overall, what is the position of the construction sector? Construction sector, if you see the chart, you'll find the raw material is the major contributor. Then comes the plant operation. Raw material, plant operation, then transportation of material, and then some, other things like labor, disruption, and all those. This is the position, and roughly the raw material constitute around 40% of the total carbon emission because of it is because of the raw material only. Another 25% because of the plant. It means these two things are indispensable, and when you will go for construction, you will have to have it. Now, let us talk about highway construction. Highway construction, the emission can be two types. Number 1 is the embodied emission, and number 2 the operational emission. What is the difference between the two? Embodied emission means something which is required for construction, operation, and life use of the structure. Say, for example, you are constructing a road, you need raw material, you need asphalt, you need cement, you need steel, whatever it is needed, and whatever are the carbon emission on account of all this, it will be constituted and termed as embodied construction. But after construction of the road, what will happen? The vehicles will ply on it. That will, the basically emission from the tailpiece of the vehicle is operational emission. We have seen in the last slide the broad breakup of the construction, how it is distributed between the raw material, the operation, and then the transportation. This is for the more on a road project. The left side you are seeing the breakup of the carbon emission for a road project, and right side of it gives a broad breakup of production of asphalt for road construction. If we see the crude oil itself constitutes a major chunk, that is 63% of the total carbon emission on account of asphalt production, and then remaining is refinery, transportation, and all those. When we talk about decarbonization, most important aspect is the coverage. Now ISO has defined, when you have to talk about decarbonization, you have to consider from cradle to crest. When I say cradle, it means from the inception till we use it last. For a road construction, just think what could be the inception and the quarrying of the material, then transportation of that quarried material from the quarry to the plant site, then mixing of all these material, running of all those plants, then transportation of this mixed material to the paving site, and then the paving. That is the construction part of it. It has been divided into a number of categories that you can see it. And the whole purpose of all these division is when we can, further zoom into individual category, let us see how best and how far we can reduce carbon emission under each of the category. The second is the use part of it. When I'll say use part of it, it means you have constructed your whole infrastructure and now you have put in use. When you are putting your road in use, what you'll have to do is you'll have to go on maintaining. Even in maintenance, it could be renewal, it could be routine maintenance, it could be rehabilitation, it could be replacement. So all has been, assigned different compartment, and under B1 to B7, this is the end use. And third part is the end use. When I say end use, it means after the life of the structure is over, how you are going to dispose it of. what is the remaining value of that material? Are you going to reuse it? So whole life cycle of a road project has been, from the point of view of carbon emission, has started from A1 and goes up to C4. This is as per the ISO classification. Now, this is just the backdrop. Why all we need all this? Just to see what we can do. What we can do, let us see what is happening internationally. Internationally, as I said, different categorization of cradle to crest use, A1 to C4, it remains the same. We'll have same compartment, we'll have to work within the same compartment, but how to work it? The first work is done by the National Asphalt Pavement Association. I am not going into all the 7 categories, but I'll give you an example how they did, how they studied, how the carbon emission can be reduced. Let us talk about first part. Say for example, construction of road. I'll have to convert the raw material into paving material. When I'll have to convert raw material into paving material, I'll have to, heat the aggregate. I'll have to heat the bitumen. I'll have to mix both of them. How I can save carbon emission in this particular phase? They have done a detailed study, and they studied one particular aspect, how the moisture content in the aggregate affects the carbon emission. It affects the productivity. It affects the, loss of energy. This is the result of the work done by NAPA on the reduction of moisture in the aggregate. What is the outcome of this? Even 1% reduction in the moisture leads to 11% reduction in the energy and 11% increase in the production of the paving material. So these are the ways by which we can introduce our system. Say for example, even in today's system, even if you see our SOPs, if you see our specification, it is written that all the aggregate to be stored in a sloping ground, it has to be kept in dry and all those. But it is the consequences we never realized. So these small works have been done, which perhaps we can also replicate, and we can work out our own equation, how the things are going to improve for our situation and how we can reduce the carbon emission. Number 2, in the same thing, what they did is, let us use REP. Sorry, if we'll use REP, how it is going to affect the CO2 emission and how it is, benefit you in terms of decarbonization. So I have given you only 3 studies. One is if I reduce the moisture content in the aggregate. Number 2, if I change the uses of REP in our pavement material. Third important aspect is if you reduce the temperature of the bituminous mixture. Now I am sure you may be having certain question in your mind how you can reduce when you have written in the specification this is the temperature for paving, laying, all those. It is not from that point of view. It is from the consideration that in case you reduce by any means, why we are heating bitumen? We are heating bitumen to get that kind of, the workability. You adapt something which can give you that workable bitumen and reduce the temperature, you can be benefited by this kind of carbon emission reduction. And this is possible. Varmix are some of the example. Again, here I'll tell you, we have all this we have done. We have a specification for all these. We have a specification for Varmix. We have a specification for recycling. Only point is we'll have to put to use. Once we have some idea about, carbon reduction by way of adopting all this, we will be in a better position to put it in use. The same comparison, the baseline, business as usual. Case 1, we have reduced the moisture by 1%, 20% rep, and 14% reduction in temperature. The case 2 is 2% reduction in moisture and 40% rep and 28-degree reduction in temperature. You will find that A1 to A3, number 1 is the plant operation, transportation, and third is the materials. You will find the material and transportation we are not changing. It remains the same. Quantum remains the same. Only plant operation will change, and you will find the reduction from 30.4 to 14.05. This is the work done by NEPA, and I have only given you the 3 examples taking from A1 to A3. There are all kind of categories. You can have number of combination. You can select your specification in such a way that you use it today and you reduce repair and maintenance during the life. Say for example, if I adopt SMA today, how it is going to affect carbon emission during the period of use life. So these are the examples where we'll have to work, and we'll have to work out all equation for ourselves. Say for example, even this particular case, if you'll see, when I said reduce temperature by 1 degree or 2 degree or reduce moisture content by 1 degree, it is on the basis of certain, plants. Those plants may be running on natural gas, and these figures related to natural gas. We are not using natural gas. What will happen in our case, that we'll have to work out. But this particular guideline, this particular work, this particular document gives us ample opportunity to carry out our own calibration, our own system, which can give you all this. The second most important document, which is now available in the public domain, is PAS 2080. Of course, it is it is not a dedicated document for highway engineers. As NAPA is concerned, it is for the highway and mostly for asphalt road. PAS 2080 is a document which deals with the construction sector, and this document only specify how you can control carbon emission in your infrastructure projects and get the best of it. So it is, it deals on a macro level. But again, this particular document gives us very good guide where we can use it and try to work on this. Now coming to the decarbonization, strategies. When we committed that we'll have to have net carbon zero by 2070, it is a commitment from the Government of India. Then what the Government of India did so far? In Government of India, they brought out 2 important documents. Again, let me tell you, all these documents will talk to you in macro level. Because when we said we are committed to net carbon zero, it is sum of all 8, 9, 10 sectors. The mining, the industry, the transport, everything. But anyway, let us see what is happening. First document is by Ministry of Economic Affairs, and it is on climate finance taxonomy. The whole idea, the whole objective of this particular document is the government is going to put resources on those sectors, in those activities which are having reduced carbon, which are sustainable. And they have covered agriculture, forestry, fisheries, infrastructure, water resources, and ecosystem. So it's a broad document, but in this broad document, they talk about infrastructure. And in infrastructure, they will have something to say about road transport as well. But when I talk about road sector, then again it will be on a very macro level. They cannot go to micro level. It will only give you a guide, which we'll have to use it and come to our conclusion, our protocol, our SOPs to meet the objective which are brought out in these documents. So what the Ministry of Economic Affairs document says, you'll have to do in such a way which mitigates, means you do use those processes, those specifications where the carbon emission is less. You try to adopt. You have adoption. Again, if it is coming, then you try to reduce, absorb whatever you would like to do it, and then super transition. So they have given you the guideline. We'll have to use it, how to do it. The second important document is on transport sector. This document has been prepared by NITI, and this has been done. It is not for India alone. It is for G20. It was prepared for G20 summit. And if you see it, as I said, the whole carbon emission can be divided into embedded and the operational. In our sector, construction sector contributes less as compared to the operation. So whole emphasis of the NITI is to, address those issues where we can save a lot. Where you can save by switching from fossil fuel to other fuels. You might have heard that they have come with C.E.G, E.N.G, then EV. So this is one way of reducing, because by switching over from one mode to the EV or the C.E.G, we are reducing carbon emission. So the NITI report concentrate only on that. Number two, they say that you switch over from one mode to the another mode which is more energy efficient. All of us know here, in the whole ecosystem, particularly in our country, let us forget about civil aviation, which takes a very small component of the total freight and passenger movement. Real competition is between road and rail. As a highway engineer, fortunately, most of the things are moved through, whether it is passenger or the freight, it is moving through road, but it is unfortunate for the society, because road is not a very efficient system in terms of CO2 emission. So whole idea of NITI to reach net carbon zero by 2070, to reduce the percentage of freight and passenger movement through road to railway. They want that the 50% of the freight and traffic should move through railways, which is today is of the order of 70 to 85% by road. So whole emphasis is to move towards railway. Not only move towards railway, even railways, you electrify the whole system, no diesel. So basically they are again addressing the macro level issues. Even when you talk about electricity, the whole emphasis, if you see the Department of Economic Affairs document, where we talked about the industry, they talk even the power sector, what we'll have to have it, we'll have to again change all the mixes there. We should move from coal-based to hydro, we'll have to move from hydro to renewable, we'll have to move for wind, we'll have to move for solar. There's a lot of emphasis, and this is being done now. Coming to the road sector, what are we doing? Of course, we are doing everything in isolation. It has not been put in a manner where I can say, as a highway engineer, I am going to reduce carbon emission by this, by adopting these means. We are doing all these in isolation. We have not, if you'll ask me, what will be my contribution towards net carbon zero it will be very difficult for me for a very simple reason, because number one, operational emission is more than the construction emission, and there it is very easy for me to handle by changing the fossil fuel to electrical vehicle. Here it is little difficult because I'll have to change whole system. Number two, I am getting a very small component of the saving rather than the kind of saving I'm getting in the operational emission. It means the operational emission is the low-hanging fruit which we would like to harness quickly and then come to this point. Then the question will certainly come to your mind whether then we should be bothered about so much if it's such a tricky issue. Friends, it's a tricky issue, but we are in a system where we'll have to ultimately reduce carbon. And as a highway professional, it is our responsibility, duty to see to it that we are contributing something to the society, particularly when we can contribute. So that is why we are discussing all this today. Now, coming to decarbonization, it is whatever is there in the country, everybody knows. How we can decarbonize? Number one, you do something which emit less carbon dioxide, or you catch hold of that carbon dioxide, don't allow it to go to atmosphere, put it somewhere, put it in such a way that it will never go to atmosphere. That is second way of doing it. And third is try to do something which converts carbon dioxide again into oxygen. That is called carbon sequestration. So these are the three strategies available with us to reduce carbon emission. Where are we and what we did? Now coming to the first part of it, reducing carbon emission on material side. We started using RAP, we are using reclaimed concrete, we are using waste material. We are doing it. Coming to the energy efficiencies, one is mode of transport. There, the government has a policy taking it up. But for the highway engineers, morning you heard about, they have all kind of vehicles which are energy efficient, unfortunately not in use. Let us move towards that. Then modify our construction method and processes. When I say modify our construction processes, again, think of these specifications. Same thing. Can we reduce temperature? Can we make our bitumen more workable at lower temperature? There could be many ways. Of course, the emulsion cold mixes are the age-old thing. You can think of something which can lead to reduction in the making it workable at lower temperature and make it. Then again, last presentation you heard, if I'll move to the technology of machine-guided control, then your productivity increases, your fuel consumption. Let us adopt all those. On carbon storage, it is something you'll have to store by a different method. There is concrete which is exposed to carbon dioxide. Concrete will absorb it, convert it into mineral. Or you can go for carbon negative materials. Or ultimately you go for sequestration, means by putting planting and all those things. You might have seen then in NHI it is one of the target fixed that so much of plantation will do, so much of the tanks will create, all those kind of things which comes under sequestration. So these are the ways by which we can do it. But problem is why we could not do it and what is really required to achieve this. Our problem is we don't have baseline. When I say baseline, whatever figure I have given it to you, it is on the basis of the certain work done abroad. They have worked out the factors and everybody is using it. There are number of calculators available from which you can calculate what is the carbon emission for doing one particular unit of work. Maybe WMM, maybe WBM, maybe DBM, BC, and in the process you can calculate carbon emission along with your estimate total CO2 emission. So we don't have this. Of course, India Road Congress has brought out a publication called India Road Congress has brought out a publication on carbon emission and scale for carbon emission. But if I have to do the kind of study and the kind of analysis which I am telling you, those standards are not adequate. We'll have to work on those standards. We'll have to not only work on those standards, we'll have to work the way NAPA has done it, that what will the impact of humidity, what will be the impact of temperature, what will be the impact of RAP, and let us develop our own baseline. Until and unless I have baseline, I can't do anything. Then number 2 is, yes, you have the baseline, you have prepared an estimate and he quotes the lower than that, then what is the way to, encourage him to use these? There you'll have to come out with a guideline. And of course, guidelines are there that is related to carbon credit, and these carbon credits are traded in the world market. What we'll have to do is we'll have to put it in place. So for putting anything in place where I'll have to give, in terms of money, you'll have to develop your equation that per ton of CO2 saved, how much you are going to compensate. So that the person who is adopting different technology can weigh various options whether it is worth going it or not going it. So we'll have to develop all these equations, how to compensate the person who is doing better work. When I'm saying compensate, it means what I'm saying is, I have prepared an estimate, my cost was 100 crore and my total CO2 emission was, say, and just guesstimate figure, maybe 150 tons of carbon dioxide. The contractor quotes me 80 crore or 120 crore, I will go by lowest and give it to him. But in the process, if we save some CO2 emission below the benchmark which I have given, I'll have to compensate him. That is the way, if I'll do it, then only we will be in a position to encourage sustainable material. Otherwise, if you'll see today, we are using all those technologies which are cheaper than the conventional technology. Example is, we have gone for cement-treated bases, sub-bases and all those, but I'll not be paid. So you'll have to pay for that. That is the second issue, and that is the incentivization which we'll have to do it. And when I'll have to do all this, we'll have to have a system of certification. Who will certify that, yes, he has saved it? That is what we are looking for. The day we'll have it, we will be in a position to decarbonize our sector, and we will achieve our objective. Thank you.
It was indeed thought-provoking session, sir. Thank you very much. Your perspectives and strategies on decarbonizing road construction and the pathway towards a sustainable future have certainly given us much to reflect upon carbon credits. Thank you, sir. As a token of appreciation, I now request Mr. Dimitrov Krishnan, MD, Volvo CE, to hand over a memento to Mr. R.K. Pandey. Vijay, sir.
Sure. I try whatever best I can. Yes, if I can answer properly, then give it.
No, give it to him.
Yeah. And pick up on Rasta.
No.
Sir has some questions.
Sir, this is an excellent topic. Yeah. This is an excellent topic and a very current topic, I would say. Are there any efforts in India to quantify the carbon dioxide? Let's say normal bitumen road, 1 kilometer, one lane, 1 kilometer, what is the CO2 emission? Then you mentioned several alternatives, including waste plastics, etc., etc. Whenever you use them, what is the reduction that happens? Think something like that?
It is an area which is of concern for everyone, and IRC brought out a document which says bituminous road, this much will be the carbon emission. It is again on the basis of the factors we have borrowed from the others.
Okay.
But if I change the composition of that bitumen, then I have nothing to do. I can't do anything. That is what we'll have to work now. If I reduce the thickness, it will give. But if I change the bitumen temperature, if I change something, I change rep, that data is not.
That data is okay.
And moreover, this whatever calculation has been done in IRC, we have borrowed it. Somebody will have to work really in Indian country.
Mine is better. Anyway, because the answer to the first question still is under working stage, maybe the answer for the second one will wait.
I'll tell you, yes. It was a question mark when we used to discuss whether concrete roads are sustainable or the bituminous roads are sustainable. It was a question mark when we used to consider what was your coverage. People were covering after construction only the repair. Then say, okay, sub concrete is better. Then when it comes to cradle to crest, ultimately it will come down to concrete is better. But let us see what is happening in our country. Are we really zero repair in concrete road?
Yeah.
If we are not zero repair, then I can't take that figures.
Yeah.
So you do something here which reflects our practices. Otherwise, our all calculation will be wrong. I'll have to do that. Unfortunately, in our country, lot of concrete road fail. Bituminous road, if fail, you can easily handle it. Concrete road failed means just imagine how we are going to handle it.
So good evening, sir. Sir, in fact, during your presentation, you did mention my question. As we all know, the cost of construction for a conventional pavement is higher. Now we have adopted the CTB as CTSB. Automatically, the cost has come down, and automatically we are going with the higher length. So now with the use of CTB and CTSB, automatically COT has increased. Carbon footprints have increased. With rough figures, as you mentioned, if we do it for a 4-lane road, the per kilometer will be around 720 tons per kilometer CO2 emission. If I am going with CTB, automatically it is going to increase. So in your area of thinking and working, what is the striking parameters where we can balance both?
Number one, you can't compare apple and orange. You'll have to convert carbon emission in terms of money. Once you have converted, then everything is money. And that conversion, you'll have to do it in our situation. Nobody can help us. We'll have to develop our own equations. Then I can say, yes, if you are saving this much, it is the cost to the society which we are willing to reimburse you.
So that means as long as we are using CTB and CTSB, reduction of...
As on today, it is not at all under my consideration. We are, I have written in red, we are literally neglecting it. We are going by L1. We don't see, if somebody comes and say, I will do with ultra high performance concrete. Number one, I don't have the, calculation for ultra high performance concrete. Number two, even if he's coming, if it is low carbon emission, I can't give preference to him. No. For that, I need, first thing is the benchmarking, where I can boldly say, Yes, he is right. Today I am not sure, because if you use calculator A, calculator B, calculator C, all the three will give you different figures. Number two, yes, benchmarking in one. Number two, how to convert it in terms of money. That is two things I need. Then
I just want to add, you are saying CTSP. See, CTSP already thickness is reduced. Sir has told it's a sustainable. And cement content is only 3 and 5%. But you are saying carbon emissions, that I have to, how you have calculated, I don't know. Because normally we are reducing the thickness, that itself is sustainable. Then the percentage content is not goes 3%, 5%, that's all maximum. So how it increases the carbon emissions? Please clarify.
Basically, what
If you take up the multiplicative factors or factors that are available for us to convert what is the carbon footprints that are going to come for production of those numbers, when you are using the cement component, is much higher. What we are seeing this thing. Yes, sir.
no, I'd say
No,
that you will have to calculate. Carbon emission for certainly cement is very high.
Yeah.
But whether it is compensated by the reduction in thickness,
Okay.
that you will have to calculate. Huh?
Okay. Thank you. Thanks.
Okay, sir. Anyone else? Okay, then thank you.
We now move on to the panel discussion session, which focus on a very important theme for the future of infrastructure. The topic for the session is automated and intelligent machine-aided highway construction, a future that is already taking shape. Automation, robotics, digital construction technologies, and intelligent machinery are rapidly transforming the highway construction ecosystem, improving productivity, safety, and sustainability. To moderate the session, we are privileged to have Dr. A.V. Raghavan, former professor at IIT Madras and technical advisor to Rasta. We are delighted to have Mr. R.K. Pandey, sir, joining us as a panelist for this session as well. After his engaging and inspiring endowment lecture, we look forward to him continuing to share his valuable perspectives in this discussion. We have Mr. Dimitrov Krishnan, Managing Director, Volvo Construction Equipment, India. He leads one of the world's leading manufacturers of construction equipment and plays a significant role in driving innovation, mechanization, and sustainable technologies for infrastructure development. Welcome you once again, sir. We have Martino J. Fernandez, Assistant Vice President and Product Head at Amman India Private Limited, who plays a key role in advancing modern construction equipment technologies and asphalt solutions for efficient and high-quality road construction. Welcome you, sir. We also have Dr. Anjan Kumar, Associate Professor at IIT Guwahati. His research focuses on transportation engineering, intelligent transportation systems, and innovative solutions for future-ready infrastructure. We are delighted to have him representing the academic perspective in this panel. With such an eminent panel, we look forward to a very engaging discussion. Over to you, sir.
Thank you, Reshma. I think we have come to the last session of the day. I think we don't want to extend further. Kavita told that we should close it at the earliest. So this session, mainly, we had a session earlier in the last session about the machinery, robotics, and construction. So this session exclusively, I just want to discuss the way forward towards the automated, intelligent machine control construction. So as you heard, there are three phases of this automated construction. It starts with the remote sensing, wherein LiDAR and three-dimensional laser scanning is possible. Using this, we will be able to get an increased level of detailed, accurate, and scalability. And we translate into efficiency, improving quantity estimates because of scanning. It provides more information on the pavement condition, guardrails, bridges, overhead structures, and even the road profile. So we get enough lakhs and lakhs, millions of data we do have. How are you going to process this data is going to be the challenge. I wish the students who are sitting here to consider this as their project work so that they become employable after the graduation. Second issue which we should talk about is on 3D design. I think using this data from the, say, as a 2D design, we have to go for a 3D design. So we are able to get more accurate information, construction documents, 3D as-built plans are possible. We will be able to visualize the engineering analysis, communication with the public. Thirdly, we will be able to detect where are the utilities. We do not know when we construct, when we tender the work. After tendering the work, we come across many utilities. So this we will be able to find out using a 3D design. It is also possible for conflict resolution. There will be advantages of 3D design in automated machine guidance, and also it helps in quantity calculations. And third aspect is the construction automation. That's what we were talking about. Construction automation involves heavy construction equipment which are guided, controlled by position, location information such as GIS, GNSS, land-based positioning system which we heard in the previous presentation. On highways, 3D design data is used to control the dozers, motor graders, trimmers, excavators, milling machines and pavers. You'll be able to give a design to the machine. The machine finally enables the construction as per your design, which is not possible with a conventional method of design. Thirdly, is it possible for us to retrofit existing automated machine control equipment? Yes, it's possible. I think Mr. Martino will be able to tell, as we don't need not import all the equipment. The existing equipment can be fitted with the retrofit can be done. The benefits are better control of the quantities, increased productivity, increased accuracy, precision of the backfill, earthwork errors, more uniform surfaces are possible. That's what we told the last session. It's also possible for us to have the reduced number of passes with improved efficiency. So outputs can be generated from the stingless pavers. Real-time quality control is possible. You will be able to get the density of compaction either from the density profiling system. You'll be able to get the thermal profile using a paver-mounted thermal profiling system, which ensures that uniform compaction to the required density to the required voice. It's also possible with a dielectric profiling system. But what we need at this point of time is a policy and guidelines for the implementation of automated intelligent machine control construction. On one hand, we talked about the machinery. What we have not talked about is about the materials. So there can be an issue with respect to materials that we are using. If the materials are not good, the machinery cannot give you a good performance. For example, when you talk about, I think Mr. Martino will be able to tell, when you talk about 20% RAP, it's okay. 40%, okay. 60%, I will think. In the ministry specification, also the 6th revision, which we under print or under discussion, we are permitted only up to 20% RAP in the wearing course. We are permitted only up to 40% RAP in the DBM. We have said that if you use a warm mix additive, up to 50% we can consider, not beyond that. There are cases of failures of 60% RAP, I think Mr. Martino will tell. It need not be due to the machinery. It may be with the plant, it may not be with the plant. But again, what matters is the quality of the materials design. We miserably fail in mixed design, especially when you have RAP, when you have high dosage of RAP. Characterizing the 60% RAP, the binder in that, I think Anjan will be able to tell much better than me, as how the binder is characterized, how to find out the percentage of workable bitumen in the RAP. He always tells that since all the payments are prematurely failed, there is a workable bitumen in the RAP. Again, there are issues and concern. How do you mix the appropriate quantity, those type of binder to get the desired performance? There are other issues also. Anjan has worked extensively on intelligent compaction. He will also share his thoughts as how intelligent compaction can ensure a better quality construction. I think most of the failures which I have investigated are due to inadequate compaction of the embankment, fill and subgrade. Other issues are with respect to subsurface drainage, especially with the gradation, thickness and many more factors that come into picture. In the case of bituminous layers, again, there are issues with respect to gradation, binder type, binder content. So many factors come into picture when you want a good quality construction. So considering all these, men, material and machinery, what the way forward towards this automated, intelligent machine control construction? So let us have this panel discussion on the way forward as how we should formulate policy guidelines. Ministry has issued a circular, but again, what are the lessons that we have learnt? Right, this is something that we have to work forward. I'm sure that academia, industry, and the ministry and the government officials will work together. So we'll have a round of discussion with the panelists as well as with the audience as the way forward. To start with, I now request Mr. DK to share his thoughts in this, the way forward.
I think I moderated the previous session to a large extent. I think I have covered all the thoughts that were in my head. But just to recap a little bit from that conversation, I would say that, I think the technology on the machinery or the systems, that is the sensing systems, is already there. It is proven, which we saw in the case study that was presented by the team. I think as stakeholders in the infrastructure space, road construction space, I think what we need to do is to help implement it more widely and more, in more projects and all of that. And where I think, which is also great to see that there is policy guidelines and, instructions released by Ministry of Road in that regard. And now it will go into tendering space and we'll start to see how it starts to propagate. I think, so I think we just need to go forward with the execution of these plans, scaling up. I think the challenge I feel which we will face in the time to come will primarily be familiarity with technology and the necessary trained manpower available for, for use of this technology. Because even Mr. Vivek and Saurabh, who were presenting, they seem to become quite comfortable after the pilot project about this technology. But how many such people are there in the whole ecosystem? So in my opinion, I see the biggest bottleneck really going forward as availability of right level of trained people to use these technologies in a systematic, integrated manner. It's great to see the initiative of NHAI to do a hackathon to try to pull in people into this, the younger talent, to attract people who are working with new technology and to attract youth to participate in this. But at the same time, I think at the end of it, what we will need is structures or systems that are fairly standardized. Whether it is at a national level, at least some level of standardization, and at least some level of standardization at the state levels too, so that everybody is starting to use that. And the other thing which came to my mind as you were speaking is also, government's decision to come up with this Gati Shakti program, which is very much about geospatial, data about all things about all kinds of infrastructure that is existing under the ground, is another area, right? Which how we will integrate to the Gati Shakti broader plan will also be very important. And maybe I would like to, of course, hear from Mr. Pandey if how when that pilot project was done, did they see the connections with that long-term goal of having I think 60 different layers in that, if I remember right, in the Gati Shakti, of various types of things that are there, and how we can connect the work we are doing with that, and how the data that is coming out of such kind of implementation is rolling into that bigger master plan of the country. So I feel it is more about implementation challenges and how we can prepare. And I feel institutions like Rasta or many other academic institutions who are participating here should take a lead in becoming more familiar with this technology, and so that they can offer programs to the people in our ecosystem in this, to gain the speed. So I think whatever role Rasta can play, I will definitely like to see how we will go forward. I was just thinking, we have been discussing about rolling out some postgraduate programs for people. What looks like these kind of ideas are some of them which should actually be implemented there. So that is my just opening comments. So over to you, Veerakunji.
Thank you. I think you rightly opened up the issue about the Gati Shakti. I think myself, Guru Vittal, we are all associated with the PMJSY program. Under the PMJSY program, now we are in phase 4. One of the topics that come into picture is about utilization of the Gati Shakti in calculating the quantity of material for the earthwork and embankment. Whereas levels we saw with Gati Shakti database, we found enormous variation in the quantity of material between Gati Shakti and the data that in the site. So we are keeping it a bit reserved. We don't enforcing at this point of time use Gati Shakti data for that. We have to fine tune this, and then before we adopt any technology that is adoptable, any software that is available. Before we move further, compaction plays an important role. That is what I had also mentioned in my presentation also about the premature failure. Anjan has worked extensively on intelligent compaction in the US as part of his postdoctoral work. He has developed guidelines. Now, how do you translate these to India? Anjan.
Good evening, everyone. Thank you, sir. India, as we know, we are the country where we are rapidly progressing in infrastructure development. As just before this panel discussion, Pandey sir mentioned that we should have automated the construction process and then started accelerating the works. But it didn't work, but we are working. Intelligent compaction is the technology what we should adopt to come out from this traditional way of quality control. When we aim for a better quality, automation is the reality. Automation is not a futuristic aspect nowadays. It is the reality because we have to have a better quality assessment when we have to construct sustainable or durable or feasible or climate resilient, any technological term pavements. And we all know highway construction is a one art where any layer is produced and transferred to field by compaction. Either it could be underlying layer, either it could be embankment, soil subgrade, subbase, base, asphaltic material, concrete, or any other varying courses we use. Compaction is one important activity. However, the assessment of this activity is being done in a very, very uncertain manner where we cannot predict or where we cannot assure the performance of created pavement assets. For example, now we see a lot of premature failures. And vis-a-vis, I have also had an experience working as an industry with L&T, which I opened up myself to the industry requirements. I could able to connect my academic and research knowledge to industry at that time. What I have seen is, why these failures? We have adhered to design guidelines, we have adhered to material specifications. All quality control reports are passing. We have adhered all guidelines. Why these failures? Not questioning the way it has functioned, whether the feedback we get when we transfer the paper design to field, whether that is reliable or not. That question can be answered with the help of continuous compaction assessment or intelligent compaction. What intelligent compaction actually does, it eliminates spot testing to full testing. It is just like scanning a human body. It continuously scans and gives the operator as well as the engineer as well as the assurance party a continuous feedback to assess whether the compaction characteristics aimed at is achieved in reality or not. And the other benefit what I see is, if the compaction is not achieved, why it is not achieved, it will indicate. The intelligent compaction technique or the automated compaction technique may not help us to make sure performance, but definitely 200% it will help us to avoid catastrophic premature failures. What I have seen in my experience, it may not directly one-to-one correlate with the density or modulus measurement. It will 100% identify poor materials. As Professor Veeravan is asking, how do we control the quality of material? So we have soil, we have aggregates, We have cement stabilized materials, we have bituminous material. In all these layers, minimum mix design is required, either from a soil. Soil mix design is nothing but determining the optimum moisture content. When it comes to wet mix macadam, again the proportioning and the moisture content. When it comes to CTSB, the proportioning, moisture content and the cement content. How do we ensure cement is added? How do we ensure the moisture content is added? One factor which will tell is the material response. When the material response to this vibration mechanism is monitored and targeted, any variation in the response is clear indication that there is a deviation in the material. For example, we check our blood pressure. The first simple test, if there is any variation, it indicates there is an issue with our physiological structure or the physiological activities. Like that, the vibration response, what we receive from the material due to the compaction forces imparted by the vibratory rollers will give us a very, very important indication about compaction. Achieving 100% compaction is a vital for performance of any road pavement sectors. And we talked about segregation. Earlier, I am here from morning. Segregation. Segregation is one of the basic challenge to all paving engineers. Either it could be granular material or bituminous material or even with the concrete. My automation can help? It will help. What does segregation constitutes? I have been investigating now. I have stopped, minimized myself going to forensic investigations. Take it from me, most of the national highway premature failures is because of, you can check, sir, first layer wet mix macadam failure on all our national highways and express highways. Because wet mix macadam, the first layer, construction industry uses grader. MOTS says use paver. They use grader, segregation is not monitored and the compaction is not achieved. And when the compaction is not achieved, how it was passed? Because we did a traditional testing. Morning NHI presented, we did 1000 square meter, do one sand replacement or 5 replacement. City gauge, sometimes it may detect weak spots, we are lucky. Sometimes it may detect where compaction has been achieved. But based on these spot measurements, we cannot ascertain the entire section of interest is done with a good compaction. There is no mapping whether 100% compaction forces is achieved across the area. There is no control to understand the thickness distribution by paver is uniform or not. There is no understanding whether the granular material is segregated or not. If the material is segregated, the coarser fraction will have a different resonance response, as Professor from RV College was discussing. If the material is not segregated, the resonant response would be different. This, the intelligent compaction can capture. But however, we are almost 60 to 70% on implementation. Various countries have come up with specifications. As we said, in India, our practices, our implementations are quite different. We may have to assess this and bring out, I request MORTH to bring out evaluating specification, not direct IRC specification. This practice in the country we should also relook. For example, in most of the DOTs where I have worked, first 1 or 2 years, they will leave the specification for industry wide the 20 to 28% reduction in the compaction cost per kilometer. So when we use this automated practice, what country is facing? In the country, I am in a remotest place in the country. I live there in Assam, Guwahati. It is almost 15,000. Wet mix macadam, sir, 9,000 rupees it is costing cubic meter. So this 30% benefit what we get with automated construction practice in the entire planning, design, construction, OEM stage, it will significantly bring down our creating cost and maintenance cost. When we bring this modern equipment, I request the schedule of rates should be revised. We cannot have a schedule of rates written for manual based construction, use the same for automated construction, because the contractor will not be able to see the benefit. And also the quality benefits is not transferred to the citizens. So that's why intelligent compaction, adopting automation. Intelligent compaction, as I mentioned, is a compaction activity. In addition to that, now we have thermal mapping for asphalt mixtures. In addition to intelligent compaction, we also have coupled image mapping, where it will help us to detect segregation during paving. As well as in asphalt plant production. I think today morning industries have presented plant modification. I am wondering, I would just close with this point. Why cannot we have multiple n number of bins? Why are still stuck with 4 bins, 5 bins, and produce the costliest or expensive material which is building the country? 1 rupee chocolate, Cadbury's eclairs have a better quality control than 15,000 rupees bituminous concrete. So we are just leaving with 4 bins. Automation should lead minimum 10 to 15 bins, make the mix the way it wants, deduct any tender mixes there only, stop that mix being transported or being placed. This is called automation. And now, as I started, this is the reality. So intelligent compaction is one component of 4 phases of highway construction.
Yeah.
Thank you, sir.
Thank you, Anjan. I think this is something that we should also discuss. For quite some time, I have been thinking, like RMC plant, why not we have for the bituminous mix also? When they are able to ensure a good quality concrete in RMC, why not we have in the bituminous mixes? This is something that we need to discuss. I think Anjan has posed some question about the hot mix plant. I now request Martino to share his thoughts on that.
Thank you, sir. Let me start with the importance of today's session. Why Rasta is important, and this is really a good example why I shifted from I have taken extra load on me from sales and marketing to training section. Hear me out. We have done a lot of study in pandemic. In pandemic, most of the people lost their job. All the sectors were down except 3 sectors, which we did our studies. First was the medical, which was required at that time. Second was communication. That's how we survived all our work. And third, surprisingly, was roads. If you need to take ambulance from point A to point B, you require roads. You want to take doctors from point here to there, you require roads. And believe me, because of our training to our salespeople, we sold maximum plants by sitting in our factory. We did not go to any contractor at all. And we have not directed any salary. Then I understood the importance of this knowledge imparting. What today we are doing this is very, very important. If you have knowledge, then it works really wonders. Coming back to the plant side, starting with the recycling, sir, what I was saying about it. Recycling is based on 2 golden rules, what we have studied so many years now. First is rep material management, and second is execution. What is rep material management? We bring that there are 2 types, 2 systems in the world how to retrieve rep from the road. One is the milling, which we know in India. Most of the time we are doing it. We mill the material, we bring it, and then we dump it to the plant site. Since India is a hot country, after some time they have lumps formation on the plant site. Second retribution of rep is by excavating. We excavate and we bring big chunks. But surprisingly in India, we don't know how to use that. So we use crusher to crush it. But in actual, Napa, sir was mentioning about Napa. Napa also mentions that is something called lump breaker. Or in Aman we have something called shredder. Shredder is nothing but to break the mastic of bitumen and filler and not the aggregates. What happens is when we crush, if we break the aggregates, we are opening inner core of the aggregate, which is white color. And then you require more bitumen to cover that into black. So, and secondly, here we have a mismatch. In India, we are not allowed to use BC as a rep. We are only allowed DBM. But when you crush, you have a lot of fine aggregates coming out. What are you going to do with that aggregates? You cannot use them in the plant because BC is not allowed. Now, sir is saying that 20% is allowed. That is nice. Same goes with milling also. Milling, we are milling both the BC and DBM. But while using, we have to use only DBM. On what are you going to do with BC? And BC is having the maximum bitumen in it. So, rep management is important. The lumps has to be broken before processing it to the plant. It should be like a rice. You can count one by one. Otherwise, it is difficult. I have got calls many times from the customers. Sir, as soon as we start mixing, the temperature which was earlier aggregate temperature was 170, it came to 120. I said, what magic you have done? Then said, no, we are using rep. I said, is the lumps there in the rep? He's saying, yes. Now, when you mechanically force the lumps to break, all the water inside, as sir has said, H2O, all the water comes out, it will bring down the temperature, and you cannot use the percentage. And that's how the rep fails in. So it's very, very important that they also understand the plant perspective. That's what I mentioned in the morning. Whenever you have to know about the plant. When you're designing, you have to know about the plants also, how to use it. Otherwise, we are having a lot of problems and a lot of failures.
Thank you. I think there's a long way to go before we bring in more percentage of RAP. I think what is needed at this point of time are the guidelines, policy guidelines, as well as specifications. What the way forward? I think request Mr. Pandey to share his thoughts on the way forward in the automation.
Before go for way forward, I'll take you to backward. Why we started with this project? This pilot project which we have taken up Lucknow. The whole idea started with the quality. And we didn't, started with a lot of quality control. We started only with to have very good finish, which very easily understood that if we'll take it from GNSS and label, we'll have very good finish. But when we started talking to the industry, that we thought, why not put all those tests which generally we'll do at the time of laying the, mixes. And even in that, apart from temperature, we have included bitumen content. But the feedback we got that it is very difficult for us to have bitumen content at this stage, so we stopped. Idea was, let us make a beginning, then go on expanding. Today, Professor said, even you can have some idea about the gradation on the basis of the response of the... So that is why the hackathon is. We have started with a small fruit. We just go on adding so that, we'll have. To be very frank, leave it to me, our whole ultimate aim is to eliminate human element from the whole quality control. Because unfortunately, everything is fine, but roads are failing. So idea is eliminate human element and construct roads. That is what the idea is. Yes, it is a fact that as a highway engineer, we don't have much, knowledge about how to do it, what to do it. There we are looking towards the industry. I'm looking towards the academia, how they can help us. And I am sure this particular hackathon, you people take part. And if you can add something, even a small component, it will be a big help to the industry. That is one part of it. Number two, it is let us come out of quality control also. Let us take full advantage of it. Let us try to avoid, duplicity of data. Data is being collected at so many points. Even to be very frank, if you'll ask me as an officer of NHI, our field offices are, tired of giving data. So another objective of this whole exercise was, nobody will have to tell me what is the progress. Sitting at one place, one can see it will go on, automatically updating my information. My people will be busy in doing something else rather than collecting this information. So with this we started. Yes, a lot of things to be done. Today, I am not sure the kind of specification. Of course, we have started with a kind of pilot. We specified some specification. I don't know. Of course, on the basis of the pilot, circular has been issued. But maybe these specifications require some further modification. You'll have to modify the specification. If our specifications are good, then I'll have to do the next turn. I'll have to see the manual results of the quality control and the results which I'm getting from the machine. And if I find that my reliability is good, then I'll have to change my contract document. I'll have to say on the basis of the machine reading, I'll accept or reject. So a lot of work to be done. It's a first step only, and sky is the limit. Sky is the limit. It is not the backward, forward. Ultimately, it will automatically result into a digital twin, which will be handed over to the someone who will be doing the asset management. And data sharing, data protocol, all these are to be, I think it is the time when we should give feedback and get those prepared in the ministry.
Yeah. Thank you. I think as rightly mentioned by you, even the initial specifications for AIMC, I circulated even to Volvo. I think Mr. Prashant was there. So we have modified Nishant, we modified, we submitted to ministry. We got from feedback from Amman also. I think there's a need for specification modification as well before it can be tendered. Yeah.
I just wanted to add one more point, Dr. Pandey mentioned about eliminating the human angle. And I want to just draw a parallel, which I mentioned earlier. I want to draw a parallel between construction industry and manufacturing industry. In manufacturing industry, for quality improvement, we implemented many things. One of the concepts is idiot proofing, it's called, Pokayokes. Pokayokes is that you are not dependent on the human to determine whether the work is done correctly. Pokayokes are foolproofing. Basically, you cannot assemble it wrongly. Because if you assemble it wrongly, it will not work. Or the gate will not open for it to move forward. It is ensured automatically. So we have recently, I'll just talk about one quality problem and how we solved it. We had a problem of leakages on main control valve on a hydraulic excavator because it is a very complex assembly. It has got 70 different joints that are fitted by humans for assembling the control valve before it goes to the main machine. This was being done by experienced people. Suddenly we had some attrition and we had to bring in new workers to do the job. They were given the task, they had the instruction, but we started to get leakages from the field. So then we realized that actually we have a competence gap. How do we? So now this is going to constantly happen if you're going to grow the industry, grow the volume and the production. You're going to have new people coming in all the time. How do you ensure that that is not, the person's intention is not wrong, but he just doesn't have the right level of knowledge enough to do it. So we implemented a digital Pokayoke. The digital Pokayoke is that every tool that is used is having an IoT device. Every spanner is an IoT device. Every torque is captured and it is tracked. There is a screen there. When he clicks, it shows green. Once he has kept the tool, it shows which is the next one. If you don't pick the next one, again it is red. So you have to assemble in a certain sequence which is fixed. You cannot make a mistake with it. So, same thing, when we said that operator is the quality controller, I think we are doing the exact same thing. Yeah. So, right? So we are converting manufacturing technology, which is already in place for the last several years, into the construction world. And this is something that we need to accelerate, and I think that's the subject that we're talking about, automation to drive. Then there was one more angle which I was just suddenly thinking, because when I was met Ministry of Road officials, one of the challenges, and if you look at the history, the amount of tendering we have done, I think the highest tenders that Ministry of Road released, I think was about 11,000 kilometers in one particular year. But we've never been able to increase that. If you want to do 60 kilometers per day, we have to do tendering of 20,000 kilometers per year. But there is a capacity gap for every step of the way, from land acquisition to everything, like projects, everything. If we do automation, we are going to free up resources. So with existing capacity, we should be able to do 2x at least, if not 3x. So I think if a business case for automation from a government perspective is very simple, actually. You just have to show that pilot project and say we have to go. Nobody is going to lose a job. We're going to increase more work will get done at lower cost and with less people. And we are struggling to attract people to come to our sector. We better do that automation.
That is not at all an issue. Government has accepted that pilot issued circulars. I do agree, as a civil engineer, we are laggard in adopting the technology. Highway engineer further go down. So, but we are willing to adopt it. Now you go on giving us whatever best you can suggest. And I again request all the students to participate in our hackathon. Even if we'll get 10 good proposals, it will be, good for us.
Yeah, thank you. I think now that what everybody is talking about is implementation, seeing the performance, collecting the data, involving the students, academia, and that's the way forward. Will we be able to take up these pilot projects? I think I request Mr. Vijaydas to tell about KIFBI. Will it be able to take any project on AAMC?
So I was listening, sir. As you are aware, we are investing a lot on quality control. Yeah. we are the first agents who have introduced the auto lab, a lab which will be moving. So any automation, quality control, because from funding agency side, we are ensuring that the executing agencies are following all the processes. So as he suggested, ensuring quality without a manual intervention. Any automation is possible, then definitely KIFBI will be in the forefront of advising it and even funding it.
Yeah, thank you. I think Murali, you are in the greater strategy of bringing up KIFBI. How do we bring in this in the KIFBI project?
Actually, in this quality control and automation, the main issue when you talk about in terms of consultancy is again trained manpower for adopting this technology. So it is for the educational institutions to ensure that the people are trained, changing from our conventional way of teaching to more skill-based, which we already discussed, and with more focus on whatever is specific to the industry that has to be taken up. So such people should be available for the consultancy organizations, and so that we can take it forward.
That also brings in another dimension about the skill development. That is what we have been talking about. Sir, will we be able to take this automation in projects of KRDCL?
Professor, you're also one of the members of the technical committee. When we meet in the next committee meeting, you can suggest as chairman and request others to support it.
Yeah, sure. Definitely. Ashwath, what is your feeling about the AIMC? About the AIMC implementation in India?
As I understand, if you go back about 25 to 26 years, 2000, I'm talking about 2000, we hardly had any, good quality roads in India. It was the NHAI's initiative which made a sea change starting from Golden Quadrilateral and then North, South, East, West corridors. So if you look back, and today we are in a similar kind of a situation where we graduated ourselves from 2000 to 2024, where earlier we used to do hardly about 1.5 to 3 kilometers a day. And now we are almost 35 to 37 kilometers of quality roads construction. So we had no resources in terms of skill, in terms of knowledge, in terms of technology, all of that, including equipments, material, all of that. So today we are in a very better position ourselves, so as to take ourselves to the next level in terms of adapting ourselves to the latest concepts, technology, skilling up. So what is required is the process, as the panelists right from the morning been talking about. It's a very useful inputs which we all have to incorporate all of that and bring in the synergy amongst the stakeholders, that is government, the contractors, equipment manufacturers, and of course the one who is on the ground to implement it. So if we do that, we can definitely do the skill development and then bring in the required resources and the technology to integrate it and take it to the next level. I'm very confident of that happening.
Thank you, Ashwath. Anyone from the audience? Yeah. I think a mic has to be given.
Hello. My question is to Martino sir. In codebook we have added usage of RAP 20%, 40%, 60%. Different mixes, but my question is to how much we practically using in the construction of our roads, in what is the percentage we are using in compared to other construction, and why we fail to implement in practical sites, even if we make the code book, but how we practically implement on the site the RAP usage.
It is being implemented. It left to the contractor, concessionaire to use it.
Sir, how much, why we failed, how much we are using RAP in current situation?
No, any project can be used. We don't prevent anybody from not using it. It's left to the concessionaire, contractor to use it. Considering the limitation of the knowledge, expertise that is available, and the plant machinery that is available, we are treading cautiously.
Sir,
Beyond 20%, I am not confident that it will work better in a varying course. Beyond 40%, I am not confident it will work better. So you construct, that's what we are taking as a trial sections. If they perform well, then definitely we will be able to implement more lengths. But as on date, there is no limitation. Any contractor can use.
I'm now asking why it is failed. Means
why it failed is a different reason.
why contractors are not using it? What are the failures?
I'll answer. Majority of the plants what we supplied, 30% of rep is been done and safely done, because 70% of the virgin aggregates are being screened well. So we know that 70% are screened. The rep you have to understand is once it is processed, no one can save it. That is the reason material management down at bottom is very, very, very important. You have to understand that what you are putting in. This 30% cold we are putting in, we are calculating everything, all the parameters. Automation we are talking about, we do all the ramping up. I sit in Bombay. From Bombay, I can see any of our plant operating on rep. I can see in my laptop. What is happening there is, I take all the data from there and then we feed it to a Switzerland-based server. And then we have all our parameters to reset them. We do all this thing same like our simulators. What we have for the flight, they usually don't fly a flight. We have simulators for rep. We sit in our offices and we run the simulators of 30%, 45%, 60%. But same thing has to be matched with the actual rep which is coming in. For example, we were talking about the moisture. The stockpile has to be kept in 20 degrees inclination, so that water should go out of that from the stockpile. Who is keeping that? I see stockpile been kept near the river, where the plant side. We tell don't put a plant side near the river. People think whatever the water is flowing is the river, but river is been in all direction. And aggregate being negative, they charge the water very quickly. So when they have a stockpile there, we say cover the stockpile so that the night all that the dew should not come on that. Water is a major factor filling of the rep. So that's the reason we start in the morning with 10%. By afternoon we go to 30. By evening we come back again to 10%. It's not 30% means you have to run whole day 30%. No, it doesn't work that way. And this is done everything automatic. Operator cannot run any of our plant. Sir, someone was mentioning about the cold feeders. How many feeders we have? We have 34 cold feeders and 19 hot bins. But I cannot supply that in India. No one is going to buy them. But in Europe, we have this something called factory. We sell the material to different customers with many cold feeders, recycling metal, DBM, BC, HDPC, name it, colored, SMA, we produce that. Technology is there. But that's what we have to learn. That's why sir is saying we just cannot jump from 20% to 60%. Till the time we don't learn about it.
But I think one word to answer this question is knowledge.
Yeah. That's right. That's what I will tell at the end. I think having heard from the morning, I think what you need at this point of time is the knowledge. I think this forum definitely would have helped the students to understand the needs. We all, I think now that AICT has reduced the number of credits for the BTech course, when I studied the 5-year engineering, now it has become 4-year engineering, now credits to 160. And from transportation engineering 2 courses to 1 course in many other institutions. In that 1 course, I have to start talking from the planning, the geometry design, traffic engineering, pavement material, pavement construction, stabilization, drainage, economics. So in that, when I talk about, I have taught the full book of highway engineering of Professor Justo in 1 semester. Now it is impossible. In that, I teach about construction for 10 hours. In that, I talk about bituminous construction for 1 hour. So in that, it's impossible for the undergraduate students to understand RAP, mixed design, construction, quality control, which the industry wants. I think that is where Rasta can play a role. Internship and professional courses which Rasta wants to offer. Please attend that course. Get yourself more knowledge so that you become employable. So the end of this panel discussion, what we learned is that there are issues with respect to the specifications, tendering process, construction, quality control, knowledge, and the skill. So this is something that unless all of us join together, it is not possible to have a good quality roads. So there are a long way to go. We will have more such programs not only such events, but also training programs to train from the operators to the engineers to the managers to the project directors. I think at all levels we need training. I'm sure that this forum has opened up a Pandora box. A lot of things that need to be discussed before we get into automated intelligent mission control construction. I'm sure the knowledge gained shared today will enable you to think. What I teach, even in my class when I have been teaching for the last 45 years, I teach the fundamentals and give enough material for students to read beyond the classroom. So this forum today has opened up a new area of into construction, which you should specialize if you want to get into payment construction, maintenance, asset management. There's no end. Because after the 64 lakh kilometers of roads that we have, this recycling and all the adapters is only for about 1.5 lakh kilometers, less than that. In rural roads, we are adopting a full depth reclamation, again a recycling technology, but again, not more than 10,000 kilometers out of the 60 lakh kilometers. So a long, long way to go in starting from initial construction to maintenance to rehabilitation. I think there's a lot of scope in highway engineering. Nobody need to feel bad for having chosen civil engineering. Definitely there's a lot of scope in civil engineering under these issues of new materials, technologies, maintenance, asset management. I'm sure that the knowledge gained will enable you to explore further in this area. And I thank all the panelists for sparing the time and sharing the knowledge about the way forward on automated, intelligent mission control construction. Thank you very much, all the panelists.
Thank you for another engaging session. Now I request Mr. Vijay Kumar sir, CEO Rasta, to hand over the memento to the moderator as well as the panelist. Last good.
Thank you. Thank you.
I think you should be giving the
I think they can go there and sit. Award.
Okay.
Next. Thank you, sir.
Yeah.
No, before you close it, I just wanted to also...
One more event in between.
Okay.
Yeah.
Okay.
Awards. Award
Okay,
for our
okay.
MTech students.
Award for the prize. But I just wanted to just say that, you know, I think the whole day, the discussions have been very enlightening, very deep, very knowledgeable, and a very receptive audience. I think it's a very excellent event. I want to just congratulate the Rasta team for having curated very relevant topics, involved the right people, and also the right audience to actually engage on this topic. And it's really been very insightful. I was only a little bit involved, but having attended it, I just want to share my thanks to the team that has been behind it. All of you, I think a big round of applause to the team Rasta that has, and the students who have really done a great job for this event.
Yeah,
So,
thank you for the
over to you.
support also, sir. Professor C.E.G. Justo Scholarship is a prestigious initiative by Rasta to recognize and encourage academic excellence among our MTech students in highway technology and infrastructure engineering. Through this scholarship, Rasta honors the outstanding performance, dedication, and commitment of students who have demonstrated exceptional academic achievement in their respective programs. We are proud to continue this tradition of supporting and motivating our bright young engineers. May I request Mr. R.K. Pandey sir, Mr. Demetro Krishnan, Professor A.V. Raghavan, Dr. Ramchandra sir, and Dr. Kavita ma'am to kindly come forward and present the scholarship honorarium to the MTech students. From Highway Technology, we have first rank holder Ms. Amrita D, who secured a total CGPA of 9.5, who also received a gold medal from VTU for her academic excellence. Second rank goes to Abhishek M with a total CGPA of 9.35. From Infrastructure, Construction and Management, we have a first rank holder, Mr. Darshan G, who also received a gold medal from VTU with a total CGPA of 8.9. We have Mr. Jayant Danvi with a total CGPA of 8.8 with second rank. Hearty congratulations to all the awardees and wish you all the success. I think all the rank holders can come here, pose for a photo with the panelists.
No, after this, sir. Come here. Come.
I haven't taught. Ma'am, that's also there. No? The MM is also there for them, no?
I'll call him.
Yeah.
Let's finish this.
If you want to. I'll just
Can you just the certificate receivers can be just wanted to.
Yeah, I'll just thank the sponsors.
Your job is over now. You go there.
Sir, I'll have to thank the sponsors.
So I just wanted to take this opportunity to get the Rasta team on stage. Sir, you've been supporting and guiding us a lot. And of course, Mr. Dr. R.K. Pandey. And we've got the rest of our team here. I think I should call, Jayanti and Dr. Jairam. Jairam was here. He was in and out. So this is basically the team that made it all happen. They worked very hard towards it. And so thank you all very much for the support. And
you are not in the frame.
Okay.
On behalf of Rasta, we sincerely thank our sponsors, Chief Patron, Volvo CE, Patrons, Petrochem Specialties, and Archides, Associate Sponsors, Sidex Industries, Kalyani Polymers, and Ramco Cements, for their valuable support and contribution towards making this event possible. Your partnership is greatly appreciated. With this, we come to the end of today's session. I now invite Mr. L. Uday Kumar, Managing Director, Sir Engineering Services, and representative from ABUHA, Association of Bangalore University Highway Engineering Alumni, to kindly deliver the vote of thanks.
Thank you, Madam. Good evening to everybody, and namaste to everyone present here. Respected dignitaries of the dais, respected teachers, fellow alumni, students and friends. We are at the culmination stage of the Professor C.E.G. Justo 7th Endowment Lecture 2026. Always we respect and treasure our teachers who facilitate the transfer of knowledge across generations for the benefit of society. A great salutation to our Guru, Professor C.E.G. Justo, who taught and demonstrated coming together is beginning, keeping together is progress, and working together is success. On behalf of ABUHI, that is Association of Bangalore University Highway Engineering Alumni, and RASTA, Center for Road Technology, it is my privilege to extend a heartfelt gratitude to all present, making today's endowment lecture a meaningful and memorable occasion. First and foremost, our deepest thanks to our esteemed speaker, Shri R.K. Pandey sir, former member, technical, NHI, and advisor to Ministry of Road Transport and Highways, for delivering such an insightful and thought-provoking lecture on decarbonizing road construction, paving way to a sustainable future. In fact, the knowledge sharing on the various sustainable pavement construction practice and strategies to achieve decarbonization of road construction sector was very well elucidated in the session. Sir, your session have not only enriched our understanding, but also has inspired us to think beyond the conventional boundaries. Thank you, sir. Indeed, it was a wonderful panel discussion on the automated intelligent mission-aided highway construction. On behalf of the organizing team, a heartfelt thanks to all the panelists, starting from Sri M. Dimitru Krishnan sir, MD Olvo, Dr. R.K. Pandey sir, and Sri Martino Fernandez sir, from the AVP and Product Head from Aman India, Dr. Anjan Kumar, Associate Professor, IIT Guwahati, for sharing your valuable time, expertise, and insight with us today. Your deep technical knowledge, practical perspectives, and engaging responses have been a booster to our technical learning. We appreciate and acknowledge your ability to simplify complex concepts and connect to the real-world application. This has made the discussion truly impactful to everyone present. Also, on behalf of the organizing committee, wish to place express our sincere gratitude and thanks to our guiding force and mentor, Professor Veeraraghavan sir, former Professor IIT Madras and Technical Advisor Rasta, for moderating the panel discussion. Sir, as always, your ability to guide the conversation with clarity, keep the discussion engaging, and ensuring every panelist's voice was heard truly elevated this session. Thank you, sir. The thoughtful questions you posed and the seamless flow you maintained created an atmosphere where a meaningful insights could shine. So once again, thank you, sir. We are equally grateful to the management of Volvo CE for their constant encouragement and vision in making this event possible. A special thanks to the organizing committee led by Dr. Kavita, Dr. Reshma, with the support of the faculty members and staff from the Rasta Center for Road Technology, whose dedication ensured the smooth execution of today's program. A big kudos to them. A big cheers to them. I must mention our deep sense of gratitude and heartfelt thanks to Professor C.E.G. Justo sir's family. That is, we have Sanjay sir, who is present here, for gracing the technical event. Thank you very much, sir. We acknowledge the generosity of the sponsors whose endowment has made this lecture series possible. In fact, your contribution is not just financial support, but an investment in knowledge, dialogue, and the future. Thank you so much. To our students and participants, thank you for your enthusiastic presence and engagement. Your curiosity is the true driving force behind such gathering as always. As Dr. APJ Abdul Kalam said, the role of teacher is like a proverbial ladder. It is used by everyone to climb up in life, but the ladder itself stays in place. We thank Professor Veeraraghavan sir for sharing us the precious lessons from Professor C.E.G. Justo sir. We are sure that at least we would put our best efforts in imbibing these practices in our day-to-day life and also on the professional front. Also, we express our gratitude. We must never forget that the highest appreciation is not to utter words, but to live by them. With that, we conclude today's session with gratitude in our hearts and renewed inspiration in our minds. Let us carry forward today's insight with purpose, passion, and the courage to create change. Thank you all. Have a wonderful day. Thank you so much.
Thank you, Uday sir, for the detailed vote of thanks. Before we disperse for high tea, I think we can have a photo session with all the participants.